Bismillahirrahmanirrahim. Hello, my dear students. I hope you are doing well. I welcome you all in class of O-level mathematics. Our discussion is continue on probability and combined events. In last two lectures, I discussed the concept of probability in brief. In today's lecture, we will discuss the following topics. How can we define probability of an event E, probability of complement, properties of probability of an event, and calculating the probability of a single event with countable outcomes. So let us start from the word equally likely outcomes. How can we define what is equally likely outcomes? Equally likely outcomes. Actually, when you perform an experiment, then this experiment has some possible outcomes. If each of possible outcome has a equal chance of occurrence, then that outcomes are called equally likely outcomes. For example, when you throw a die which have a six-faced, so a six-faced die you now have a six outcomes: 1, 2, 3, 4, 5, 6. Now every outcome has a same chance of occurrence, that is 1 over 6, 1 over 6, 1 over 6. So throwing a die, so the outcomes on a single die represent the equally likely outcomes. Similarly, when you toss a coin, it has two possible outcomes, and if coin is fair, then each of outcome head or tail represent equally likely, because each outcome has an equal chance of occurrence, that is 0.5. Now we define what is the probability of an event. Let an experiment has equally likely outcomes, then probability of an event E, is denoted by P of E, and is defined as probability of E is equal to favorable number of favorable, you will write here number of favorable outcomes, for E, divided by total possible outcomes. That you can write it as also probability of E is equal to n of E, mean to say number of favorable outcome for E, divided by n of S, total number of possible outcome in a sample space. So this is the formula of probability of an event E. For example, when you throw a die, then the total possible outcomes, 1, 2, 3, 4, 5, 6. So this is the sample space for the outcomes of a single die. Now if event E represent even numbers, occurrence of even numbers, or even dots, then probability of E is equal to, you can count here how many numbers are even. There are 1, 2, 3. So there are the possible number of outcomes for event E, that is the favorable outcome. These are 3 out of total possible outcome 6. 3 over 6, that is 1 by 2. So the probability of an even number on a single die is 1 by 2, that is 0.5. Next we define what is the probability of complement. The probability of complement of an event E is simply denoted by probability of E dash. E dash mean complement of E. Complement of E mean not E. E will not occur. This is equal to 1 minus probability of E. 1 minus probability of E. For example, in this example, we say what is the probability of E complement? Probability of E complement mean probability of E complement in that example means the occurrence number is not an even number. It means it will be odd number. So you can find probability of E complement by using 2 ways. One is by this formula, probability of E complement, that is 1 minus probability of E. 1 minus probability of E. Probability of E is 1 by 2. This is 1 minus 1 by 2. This is equal to 1 by 2 here. And the other way to find the probability of E complement is directly you can find what is the probability of odd numbers. When a number is not an even number, it means that would be an odd number. So what is the probability of odd number is here. Probability of odd number is, there are 3 odd out of 6. Again, this is 1 by 2. So this is the concept of probability of an event and its complement. Next we define what are the properties of probability of an event. Properties of an event. Okay. Properties of probability of an event. The first property is total probability is 1 for a sample space S. A sample space S may have a finite number of events. In mathematical definition, you can write it as I is equal to 1 to n if the possible outcome for a sample space are n. Then probability of AI mean to say the sum of the probability of all events of a sample space is equal to 1. And sometime you can write it as also probability of E plus probability of its complement. This is equal to 1. So this is the first definition, first property of probability. Properties of probability. The second property is probability of any event lies between 0 and 1. Now there are the two cases here. Probability of A is 0. If probability of A is 0, this shows that A is an impossible event. This shows A is an impossible event. Impossible means it cannot occur. For example, when you throw a die, you say the outcome will be 7. This is not possible. If we have a 6-phase die, then it has only 6 outcomes, 1, 2, 3, 4, 5, 6. There is no outcome of 7. So occurrence of 7 on a single die is not possible. In that case, A will be impossible event and its probability will be 0. Probability of A is equal to 1 mean this is a sure event. This implies A is sure event. A is sure event. For example, when you throw a die, you say the outcome will be between 1 to 6. So this will always occur because there is no other outcomes other than 1 to 6. So if A represent that the outcomes will be exactly from 1 to 6, then A is a sure event and its probability will be 1. So these are the two properties of probabilities. Next we discuss on some numerical examples, numerical questions. How to find the probability of a single event. In this lecture we will discuss the case with countable outcomes. Because when we find the probability of an event, there are the two types for that event. Either it has a possible outcome, or it may have a it has a countable outcome, or it has uncountable outcomes. So let us discuss. Okay. Next we are going to discuss two numerical examples, and these two numerical example I am choosing from this new Syllabus Mathematics series. Actually, this book is very close to your O-level final exam. So these are very nice and easy to understand problems. I hope you have you have this book. Otherwise, I am sharing the question on screen. You can firstly read the question, then we will solve this. So question number 2 is, question number 1 is very easy, and after these two questions, I hope you can do the question number 1 by yourself. Question number 2, there are 2 green marbles and 3 yellow marbles. There are 2 types of colors here. Green, there are green marbles 2, and yellow marbles are 3. It means total are 5. This is exercise 2A. The marbles are identical except for their colors. There is no other difference other than their colors. Their physical appearance is same. A marble is drawn at a random from the bag. A marble, only one marble is drawn from the bag. List the sample space in a set notation. Firstly, we have to make sample space. The sample space S is given by, there are the 2 green marbles, so we will write it at G1, G2, and there are 3 yellow marbles, you will write Y1, Y2, Y3. So this is simple sample space. Second part, by using the set notation for the respective events, find the probability that the marble is yellow. Now we have to find the probability of yellow marble. Probability of yellow marbles. You can notice that there are 3 yellow marbles here out of 5. So this is the probability of yellow marble, 3 by 5. This is the second part. Second A. Now second B. Not yellow. Next we have to find probability of not yellow. That is Y complement. Yellow complement. Not yellowing. It is given by 1 minus probability of yellow. Probability of yellow is 3 by 5. This is 1 minus 3 by 5. That is 2 by 5. And you can find complement of yellow marble simply when the marble is not yellow. It means this is understood that your marble is green, and your marble are green marble are 2 out of 5. Again, you will reach at the same answer. Third part. In the third part, you have to find what is the probability that the marble drawn is black. Probability of black marble. You can notice that there is no black marble here. There are only 2 colors of marbles, green and yellow. It means this is an impossible event. So that's why the probability of black marble is 0. Probability of its B part. Probability of green or yellow. Yes, this is interesting. Throughout the chapter, you will find there are the 2 types of probability. Probability of A or B. You will find often you will find 2 words, or and second is and. In case of or, you will always add or probability of both events, and in case of and, you will multiply. So here you have to find the probability of green or yellow. There is no single marble which have a both colors. Either it is green or it is yellow. So the probability is simply given by probability of green marble plus probability of yellow marble. What is the probability of green marble? Green marble are 2 out of 5. This is 2 by 5 plus yellow marble are 3 out of 5. So this is 5 by 5. Total probability is equal to 1. This is your answer. And it completes the question. Okay. The next one, question number 3, is also interesting, and this type of question also asked in your final exam. Question number 3. Question number 3 here. Question number 3 says, firstly, I am sharing the question number 3. You read this question. Each letter of the word probability, there is a word probability, PROBABILITY. Each letter of the word probability is written on identical card. There are some identical cards. Identical card mean they have same dimensions. So on each card, we are writing one letter. One card is chosen at a random. List the sample space in a set notation. List the sample space in set notation. You have to make sample space here. The sample space is simply given by this letter, but separating by comma. So this is PROBABILITY. So this is the sample space. Next, what is the probability that the letter on the chosen card is? Now you have to choose a single card. What is the probability? What is the probability? The letter on the card is B. Letter on the card is B. This is very simple. You have to see probability of letter is probability of card having a B letter. Total letters are here. Total letters are here 11. Mean to say number of sample space is equal to 11. Now, how many times B appear here? B is 2 times here. In the word probability, the letter B occurs 2 times. So the favorable outcome for B is 2 out of 11. So this is the probability of B. The next letter is T. Letter is T. Probability of letter is T. T is occur only one time. So its probability is 1 by 11. The next one is NT or NO. Or NT or O. As an above question, I have told you that in case of OR, you will always add the probability of both of events. So in this case, answer is probability of T plus probability of O. So probability of T is 1 over 11. This is 1 over 11 plus probability of O. O occur also one time. So total this probability is 2 over 11. The next one is NE. Probability of E. Letter is E. You can notice that there is no letter E occur in the letters of probability. So this is an impossible event. So its probability is 0. Next is its third part. By using a set notation for the respective events, find the probability that the letter chosen is a vowel. Now you have to find the probability of vowel words. Probability of vowel. In the spellings of probability, How many letters are vowel here? Probability of vowels. Vowels are, the first vowel is O. This is 1, 2, 3, 4. As I occur 2 times, so we will consider both of the cases. So there are the 4 letters that are vowels. So probability of vowel is 4 by 11. Next one is probability of consonants. Consonants. You can find its probability by using 2 ways. The first way is way of complement, because when you say the letter is a consonant, it means it will be not vowels. So we have to find the probability of not vowel. Not vowel mean consonants. So this is given by 1 minus probability of vowels, that is 4 by 11. This is equal to 7 by 11. The other way, you can directly count the consonant in this word probability. The consonants are, the first consonant is P, 1, 2, third is B, again is B, 4, 5, 6 and 7. So I hope these are very interesting questions, and today lecture is also very enjoyable. You have enjoyed from today lecture. Still, if you have any problem, question, query, you can message me. Inshallah, I will reply you. If you find my videos helpful, kindly like, share and subscribe my channel. See you in the next lecture. Inshallah, in the next lecture, we will discuss the case of uncountable outcomes. How to find the probability in case of uncountable outcomes. That is also very interesting. So see you in the next lecture. Take care. Allah Hafiz.